students. Dear children, today we are going to start 5th chapter of Maths Paper 2, 10th Standard SSC. Dear students, name of this chapter is Coordinate Geometry. Let us try to understand what we are going to study here. Dear children, if I am taking x-axis and I am taking y-axis, then the point of intersection becomes origin, denoted by 0, 0. Again, this board consider as the plane surface. बोर्ड क्या है? एक प्लेन सरफेस है. Now this is the x-axis and this is the y-axis. If suppose I do the equidistant markings, equidistant means equal distance पे हमें मार्किंग करना है. 1, 2, 3, 4, 5, 6, 7, 8 and so on. Similarly, even this side we can do the equidistant markings as -1, -2, -3, -4, -5, -6, -7, -8. So it becomes the negative side and this becomes the positive side of the x-axis. Similarly, for y-axis, here this side will denote the positive numbers 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. Downside indicates the negative number. Now children, this coordinate system becomes very useful in finding the location of any point. If suppose a point is here, say A, I will drop a perpendicular from here, as well I will drop a perpendicular to y-axis, and this point 3, 3 will be the notation. Similarly, if suppose I have to go on a point B which is having address of 5 and say 4. This 5 indicates you have to move on the x-axis. This indicates that you have to move on the y-axis. On x-axis, if I am moving 5 steps, 1, 2, 3, 4, now here 5. On y-axis, I have to move 4 steps. 4 steps. If suppose I am taking that as -4, then I will move 1, 2, 3, 4, 5. Now minus means I have to move on the negative side. So 1, 2, 3 and 4. So from here and from here means the point B is located here, 5 and -4. It is this point where the point B is located. Now children, first number denotes the x coordinate value and the second number denotes the y coordinate value. Now I will just erase this part. If suppose you have to find the distance between these 2 points, point A and point B, what you have to do? You have to find the distance between 2 points, point A and point B. So we will be using a formula known as distance formula. If any point is A, x1, y1, any point is B, x2, y2, then length AB will be calculated as x2 minus x1 का whole square plus y2 minus y1 का whole square. It's very easy and very simple formula known as the distance formula. Distance formula enables you to find the distance. If suppose you have to find the distance between 2 points A and B, then by using the formula directly you can calculate. So let us see what is the formula. If the point A is x1, y1 and point B is x2, y2, then formula tells you length AB is going to be square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now children, let's solve the question by using this formula. What I will be doing, while calculating length AB, I will just substitute the respective values. Consider this value as x1, y1 and this value as the x2, y2. So x1, y1 and x2, y2. If suppose you are taking this as x2, y2, then this you have to take as the x1, y1. That is allowed. So here in our example, I am taking A as x1, y1 and B as x2 values. x2 value is 5 minus x1 value is 3 the whole square plus y2 value is minus 4, y1 value is minus 3. So length AB is going to be 5 minus 3 which is 2 ka square and 4 minus 3 which is 7 ka square. 2 ka square is 4, 7 ka square is 49. So answer comes out as 53. So length AB in this case is under root 53. So children, this way we have used the distance formula and calculated a distance between point A and point B. Now, by using the same formula, we will solve exercise 5.1, which is given in exercise 5.1, and this is second question of first group. They are asking you to find the distance between point P and point Q. So, while solving the question, we will write, let point P is x1, y1 and point Q is x2, y2. So, P minus 5 and 7, Q is minus 1 and 3. On this basis, we can say that x1 is minus 5 and y1 is 7. x1 is minus 5, y1 is 7. Again, x2 is minus 1 and y2 is what? 3. Now we will write by distance formula, length PQ is going to be x2 minus x1 the whole square, y2 minus y1 the whole square. So length PQ is going to be x2 minus x1 the whole square, y2 minus y1 the whole square. Length PQ is minus 1 plus 5 is what? 4 the whole square. 3 minus 7 is what? Minus 4 the square. Length PQ is going to be 16 plus 16. Length PQ is going to be 16 plus 16 becomes 32. So, length PQ can also be written as 16 into 2. 16 I will take outside, out of the root. So, it becomes 4 root 2. So, this is the answer for length PQ. This much units. This much unit. Since this is a distance, so it may be having a unit of centimeter, meter, whatsoever. Just we are ending by writing unit. So children, even other questions are same, only numbers are changing. So you try all those questions. If you have got any doubt, difficulty regarding that, you can ask me. So now it's time to move further. Dear children, in the second question, they are asking, determine whether the points are collinear. Now what is the meaning of collinear points? Collinear means if suppose points are on the same line A, B and C, then only we say that points are collinear. Now let us see how a distance factor can help us in proving whether the points are collinear or not. If suppose this distance is 2 unit and the distance between B and C is 3 unit, distance between A and C has to be 5 unit. It will neither be less nor be more. And this is possible only if the points are collinear. Now see the situation when the points are non-collinear. This is the situation for the collinear points. Now talk about the non-collinear points. If suppose a point A is here, point B is here and point C is here. In such case, if this distance is 2, this distance is say 4, this distance is 3. Or just I will say this distance is 5. Definitely, any two distances if you are adding, they are not equal to the third distance. This is known as the non-collinear points. How it is possible? Now see, if the point B is on the, suppose I am taking a line. I am taking 1 point here, 1 point here and 1 point here. Then definitely this plus this is going to be overall. This much plus this much is going to be this much. That same we wrote with the example. Suppose this is 2, this is 4. This has to be 6. Am I right? 2 plus 4 is definitely going to be 6. This is possible only if the points are collinear. And if suppose I am taking B somewhere here, then this distance will be different, this distance will be different, because they are forming a triangle. And always remember, sum of the two sides of any triangle is bigger, is more, is greater than the third side. Sum of any two side is greater than the third side. So they are non-collinear, and the points which are non-collinear, which are not on the same line, they form a triangle. So here we will be using the same concept for proving that the points are collinear. So let us see how we are using it. What I will be doing, I will first find out length AB. We will write here by distance formula. Length AB is going to be, directly you can use, consider this as x1, y1, this as x2, y2. Write x2 minus x1 the whole square, y2 minus y1 the whole square. Length AB is going to be x2 minus x1 the whole square, y2 y1 the whole square. Length AB is going to be 2 minus 1, which is 1, minus 5 plus 3 is minus 2. So length AB is going to be 1 plus 4, that is under root 5. Dear children, this is the value of length AB. Now we will be finding length BC. So again, length BC, while calculating length BC, you consider this as x1 as y1 and this as x2 and y2. That you can do. Consider this one now as x1 y1 and this as the x2 y2. So we will be now using the formula x2 minus x1 the whole square, y2 minus y1 the whole square. Put the values. X2 is what? Minus 4. X1 is what? Minus 2 the whole square. Y2 7 minus 5 the whole square. Minus 4 minus 2 becomes minus 6 the square. 7 plus 5 12 the square. This becomes 36. This becomes 144. So this comes out to be 36, that is 180. 5, 6 root 5. If suppose you are finding how we got this step, it's very easy to calculate. You take 180 divided by 2, 90, then 45, then you can divide it by say 3, 15, now 3, 5 ja, then 5, 1. Now under root 180, I can also write as 2 into 2, 3 into 3 into 5. Out of this one pair, 2 into 2, these 2 will come out. Out of this pair, 1, 3 will also come out. Inside 5 will remain. 2 into 3 will become 6 root 5. So this way you can simplify a bigger number in this form. Now we will be solving. After we calculated AB, we calculated BC. Now what we have to calculate? AC. So the third distance, what we are going to calculate is AC. Here we will write length AC is going to be, again by using the formula, x2 minus x1 the whole square, y2 minus y1 the whole square. Length AC will be, while calculating, you write here what is the value of A, 1 and minus 3, what is the value of C, minus 4 and 7. Here you can write x1, y1, here you can say this is x2, y2. Now put the value of x2 minus 4, x1 minus 1, the whole square, y2 minus y1, the whole square. Length AC is going to be minus 4 minus 1, minus 5 the square, 7 plus 3, 10 the square. Length AC is going to be 5 the square is 25, 10 the square is 100. So length AC is now 125. This value again we will simplify with our usual method. 5, this 5 5 ja. It means that under root 125 is 5 into 5 into 5. Out of these three values, 1 5 will come out. So I am writing 5 root 5. Length AC is 5 root 5. Now children, you can see that length AB plus length AC equals to length BC. We will prove it. Length AB plus length AC equals to what? Length AB is root 5. Length AC is 5 root 5. Now remember, if suppose I am asking x plus 5x, what will you say? You will write 6x. Similarly, here if nothing is written but still 1 is there. So 1 root 5 and 5 root 5. There are total 6 root 5s. So you can say it is 6 root 5. But 6 root 5 is the value of what? Value of BC. So you can say length of BC is also 6 root 5. So you can declare length AB plus length AC is length BC. So point A, B, C are collinear. B to A to C. So B to A means AB, and AB value is root 5. AC value is 5 root 5, and this entire value is 6 root 5. It is like this. So children, this way we have proved that since the distance between BA plus distance between AC equals to distance between BC, hence point BAC are what? Collinear. Okay, so now it's time to move for the next question. The x-axis, which is equidistant from A and B. It means that if suppose this is the y-axis and this is the x-axis, x-axis and the y-axis. Find the point on the x-axis. There is a point. And the point is somewhere on the x-axis. There is a point A, 3 and 4. 3 and 4, somewhere here. And there is a point B, 1 and 4. Somewhere say here. This point P is equidistant, having equal distance from A as well as from B. Now children, there is no need to draw the diagram. Without diagram we can solve it very easily. Just you say, let P, X, Y be any point on x-axis such that length of PA equals to length of PB. They have given that the point P is equidistant. Equidistant means the distance is equal. Distance PA is equal to distance PB. If both the distances are equal, we can say that length PA equals to length PB. Also, but point P is on the x-axis. So, Pxy, x is going to be 0. So, we can say is on the x-axis. So, P will be x and 0. Why? Because point P is on the x-axis, and any point on the x-axis will have y value as 0. So, I am writing y value as 0. We have to calculate length PA. P value is x and 0. A value is given to us minus 3 and 4. This x1, y1, this x2, y2. Length PA is going to be x2 minus x1 the whole square, y2 minus y1 the whole square. Length PA is going to be now x2 minus x1 the whole square, y2 minus y1 the whole square. So, this is going to be minus 3 minus x the whole square, and here 4 square as 16. For the time being, we will leave this one as it is, and we will move for the next, that is length of PB. P value is what? P value is x and 0. B value is what? B value is 1 and minus 4. This is x1, y1. This is x2, y2. Length PB is going to be x2 minus x1 the whole square, y2 minus y1 the whole square. x2 minus x1 the whole square plus y2 minus y1 the whole square. 1 minus x the whole square minus 4 the square, 1 minus x square plus 16. Now children, here x1 value was x and x2 value was 1. So we substituted all the values and we calculated length PB as well. Now, but length PA equals to length PB. This is given to us. If these values are given, I can now write root of minus 3 minus x square plus 16 is equals to 1 minus x square plus 16. Now you can say squaring on both the sides. Squaring on both the sides. So minus 3 minus x whole square plus 16. 1 minus x square plus 16. Now children, 16 and 16 will get cancelled because both are positive and both are on the both sides. So here it becomes minus by taking outside. This value will become 3 plus x square equals to 1 minus x square. How it becomes like this? I will take one step. If I am taking minus common, it becomes 3 plus x. Overall square is already there. This is minus and this is minus. So minus minus I have taken outside. So it has become plus. If you open the bracket, you will get back the original value. Now, because of the square, this minus will become plus. That's why I am writing this step. Now, I will be using very simple formula of a plus b whole square. 3 ka square. What is the formula of a plus b whole square? Tell me. A plus b whole square is a square plus 2ab plus b ka square. So, 3 ka square is 9 plus 6x plus x ka square, 1 minus 2x plus x ka square, x square will get cancelled. 9 you take to this side, it becomes 8. 6 you take to other side, it becomes minus 2x minus 6x. 8 is going to be minus 8x. And x value is going to be 8 by 8 minus, so we cancel minus 1. X value is coming out as minus 1. Already the point is having y value as 0, x all we calculated. So here your answer comes. Answer point P is minus 1 and 0. So children, this way we have calculated. So please solve all these questions. Now let us see what the question is telling. Verify that point this and this are the vertices of a right angled triangle. Anyhow, if suppose we have to prove that it's a right angled triangle, then definitely children we are going to use the Pythagoras theorem, and for that purpose we need the distances of this triangle. So let us see, while solving we will say that point P is minus 2 and 2, point Q is 2 and 2, and point R is 2 and 7. Length PQ we have to calculate. So P is this value, Q is this value. Consider x1, y1, x2, y2. Write the formula PQ. What is the formula PQ? x2 minus x1 the whole square, y2 minus y1 the whole square. So length PQ is going to become x2 minus x1 the whole square, y2 minus y1 the whole square. Length PQ is simply 2 plus 2, that is 4 pi square. 2 minus 2 comes out as 0. So here length of PQ comes out as under root 4 chi square, which is finally 4. What we are doing, we are just substituting the values. x2 is 2, x1 is minus 2, so it becomes plus because of minus and minus. So we have solved it, and other side y2 minus y1 becomes 0, and length PQ we calculated. Similarly, we will calculate length QR. So length QR we have to calculate. Q value is 2 and 2, R value is 2 and 7. You can say that this one x1 y1, this as x2 y2. Now length QR is going to be x2 minus x1 the whole square, y2 minus y1 the whole square. Length QR is going to be x2 minus x1 the whole square, y2 minus y1 the whole square. So length QR will be 2 minus 2 means 0, 7 minus 2 means 5 the square. Length QR is going to be under root 25. So Similarly, now we will calculate PR. Length PR is what that we have to calculate. So PR, P value is given to you, minus 2 and 2, x1, y1. R value is also given to you, 2 and 7, x2, y2. So length PR is going to be x2 minus x1 the whole square plus y2 minus y1 the whole square under root 2 minus 2 the whole square, then 7 minus 2 the whole square. This comes out 4 the square, this comes out 5 the square. Here the value 4 the square is 16, 5 the square is 25, and if you calculate it, it will come out as 41. So this way we have got these three values. Now let us see what relation do they have. This value QR I will write as 5 because under root 25 will become finally 5. Now you can see that for Pythagoras theorem we need all square values. So what I will be doing, I will calculate square values of all these three distances. Length PQ is 4. So length PQ का square will be 16. Length QR is 5. Length QR square is 25. Length PR is under root 41. Length PR square is going to be 41. Now children, we will now see right here length QR का square plus length PQ का square equals to 16 plus 25, which is 41. Length PR square is already 41. So from first and second, here I am writing from first and second, length QR का square plus length PQ का square equals to length PR का square. So by converse of Pythagoras theorem, triangle PQR is right angled triangle, and even we can show that PQ and PR means Q value is common here. This is P, this is R. PQ, PQR triangle is a right angled triangle. So children, this way you can prove that the given points are actually representing a right angled triangle, because sum of the two sides PQ plus QR is equal to the square of PR. Sum of PQ and QR equals to PR. This becomes hypotenuse, and these are the adjacent sides.